Hi everyone. Welcome back to this channel. So in the previous session, we were discussed about the group 16th elements. Under the group 16th elements, the compounds of group 16th elements: oxygen, ozone, and the sulfur. The all group 16th elements shows allotropies. Because of that, uh, oxygen shows allotropy, oxygen and ozone. Next is sulfur. Sulfur shows allotropy, alpha sulfur, beta sulfur. What are the properties of allotropies of sulfur? And all these things we are discussed in the last class. The sulfur shows two types of allotropy, mainly rhombic sulfur and monoclinic sulfur, nothing but alpha and beta sulfurs. The stability of alpha sulfur, beta sulfur, and what is the transition point? It is 369 Kelvin. At that point, both alpha beta sulfurs are more stable, and one shows solubility in water, another does not show solubility in water, and both are soluble in carbon disulfide. So these all property were discussed in the last class. Let's move on to the compounds of the sulfur. The compounds of sulfur, the first compound of sulfur is sulphur dioxide. Okay, let's move on to the study of sulphur dioxide. Sulphur dioxide is represented SO2 in the form of SO2, sulphur dioxide. Now, what are the method of preparation of sulphur dioxide, and what are the important properties, and what are the uses of the sulphur dioxide, and what are the other compounds from sulphur dioxide? There are different types of compounds formed from sulphur dioxide. First thing is preparation method. Okay, preparation of sulphur dioxide. The preparation method. Under the preparation method of sulphur dioxide is prepared using different method from sulphide ore. The better way of preparation of the sulphur dioxide is from sulphide ore and also from sulphides. There are different types of sulphides that exist. From that we prepare sulphur dioxide. And the very primary method, okay, the primary method of preparation of sulphur dioxide, the first one is from the ore of sulphur. When sulphurs are, or sulphur that directly obtained from earth crust in the form ore, and this sulphur ore is burned in presence of air. Okay, what happened when sulphurs are burned? Solid. So this is a solid sulphur. When solid sulphurs are burned in presence of oxygen, okay, when solid sulphurs are burned in presence of oxygen gas, it gives sulphur dioxide, the gas, sulphur dioxide. During the preparation of sulphur dioxide from sulphur, there is a possibility of formation of a sulphur trioxide also. How much quantity? Around 10%, 8 to 10% of formation of sulphur trioxide is possible during the burning of the sulphur. We extract only sulphur dioxide, and it is the method of preparation of sulphur from the sulphur ore. So it is just a simple method. From this method we obtain the sulphur dioxide, but it involves special conditions and the requirement and all that, because most of the sulphur ore or the solids form of the sulphur mainly contain arsenic. The arsenic impurity also present with the sulfur dioxide gas. Therefore, we need a purification purification method. Now, after purification of the gas, we get a pure sulfur dioxide. Okay, so this is the one method. Next, second method is from sulphide. Okay, what are the different types of sulphides? There are a lot of sulphides ores are there. Ferrous sulphide, calcium fluoride, calcium sulphide. Next, these metallic sulphides. Different types of metallic sulphides are there. Mainly iron sulphide. When iron sulphides, okay, iron sulphide, FeS2, it is exist in the form of FeS2. Okay, all these reactions are very important for your exam point of view. When ferrous sulphide ore is made to react with oxygen or burn in oxygen, all sulphide ores are burned, we get a sulfur dioxide. Okay, it get converted into Fe2O3 plus SO2. To balancing this reaction, okay, so this is the sulphide ore solid state, it is a gaseous state. Again it is solid state, it is a gas. Okay. When sulphide ore is burned in presence of oxygen, it gives sulfur dioxide gas. Then how to balance this reaction? So here two S are there, sulphides are here, one, here only Fe, here Fe2. So first I multiplied 2 because it is an odd number. To make it even, I multiplied 2, it becomes 6 now, and 2 into 2, 4. Fe become 4 means Fe, 4 Fe, S2. Here 2 into 4, how much? 8 sulfurs are there. Here only 1, therefore I multiply 8 here. 8 into 2, how much? 16. 2 into 3, 6. 16 plus 6, 22. Here only 2. So therefore I multiply 11 to the oxygen. So this is the balanced chemical equation. So here sulphide ore is burned in presence of excess of oxygen, we get sulfur dioxide gas. So this is another method of preparation of sulfur dioxide. Next, from sulphide, not sulfates, okay, sulphides. Next method is from sulphides. The meaning of sulphides. Sulphides, nothing but is an ion. It is in the form of SO3 2 minus. Okay, it is SO3 2 minus. SO4 2 minus is sulphate. SO3 2 minus is sulphide because of the oxidation state. Variable oxidation state of sulfur, we use the different suffixes for during the naming of the ions. Sulphide ore. When sulphide ore is treated with the acid, it gives sulfur dioxide and water. Okay, so this is the another method. Okay, so here I multiply 2, it become 4. Okay, to make a even number I multiply, oxygen should be even number, therefore I multiply 2 into 2, how much? 4 hydrogen. In the product side there are 4 hydrogen, therefore I multiply 4 to this acid, it becomes 4 hydrogen. And now how much oxygens are there? 2 oxygens are there, here 2 oxygens are there, 4 oxygen. So 4 oxygen is here, in this case only 3 oxygen, and the number of electrons also should also balanced in this case. Therefore, I multiply or directly multiply 2 here. It is possible. No? Correct. Okay. When multiply 2 to the acid, 3 oxygen, 3 oxygen, 2 hydrogen, 2 hydrogen, 1 sulfur, 1 sulfur, and electrons also balanced. Dear students, you should remember the thing during the balancing the ionic equation. We should give the concentration on the electrons also. Here there are 2 electrons variable is observed. Here also 2 electron lost in one case and 2 electron gain in another case. So these also balanced. Not only molecules or atoms, the electron should be balanced during the balancing the ionic equation. Okay, so this is the another method of preparation of sulfur dioxide. How? When sulfides, this equation is important. Okay, this equation is important for your exam point of view. When sulfide ore is made to treated with acid, any sulfide, you can take sodium sulfide, potassium sulfide, calcium sulfide, any sulfides are treated with an acid, any acid like a sulfuric acid, so not on sulfuric acid, HCl, hydrochloric acid or phosphoric acid, then it gives sulfur dioxide gas. Okay, so this is the another method of preparation of sulfur dioxide. So these three are the very important method of preparation of sulfur dioxide. Let us discuss about the properties of sulfur dioxide. Structural property. Okay, the first thing is physical property. As you know that under the property we should first we should study the physical property, next by the chemical property. In the physical property, sulfur dioxide is a pungent gas. Okay, it has odor. It's a colorless, pungent gas. Colorless, pungent gas, pungent odor. Okay, so we can easily identify the sulfur dioxide on the basis of the pungent odor. So in all the cases, where the quantity of sulfur dioxides are formed, they give the pungent odor that gives the identification of the presence of the sulfur dioxide. Next, sulfur dioxide has a boiling point. It is very near to the room temperature, and 2 atmospheric pressure is enough to liquefy the gas. Okay, 2 atmospheric pressure is enough to liquefy. Okay, so these are the general things, but for knowledge purpose we need all these things. Okay, when just you apply the pressure on the sulfur dioxide gas, it gets converted into a liquid state. Otherwise, in the ordinary condition, in the room temperature and 1 atmospheric pressure, it is gas. You just decrease the temperature and apply a small amount of pressure, it gets converted into a liquid. Whatever we prepared sulfur dioxide during the in a laboratory using the laboratory reagent and all that, at that condition it is a liquid. Just you release the pressure, or just it opens to the atmosphere condition, that it converted into a gas, pungent odor gas. So this is about the sulfur dioxide physical property. It is a non-metallic. Okay, it is a non-metallic. It's soluble in water. Okay, it's soluble in water. Can anybody soluble in water? Can anybody guess what may be the product when sulfur dioxide is soluble in water? What happened when sulfur dioxide is made to react with water? It's an interesting thing. When sulfur dioxide is dissolved in water, it's a chemical property, okay, not a physical property, but it's soluble. Why it's soluble, and what are the different compounds are formed? No, there is no different compounds. Only one product is formed. When sulfur dioxide is dissolved in water, H2O, it converted into sulfuric acid. So this things will be discussed in the chemical property. Okay, under chemical property. So this is about the physical property of sulfur dioxide. Let us move on to the structural property of sulfur dioxide. What is the structure of sulfur dioxide? It shows resonating stability. The canonical form of sulfur dioxide is after a resonating structure. So these are the two resonating structure. Because of the resonance, it is slightly stable. Otherwise, it does not exist in the form of sulfur dioxide. It gets converted into sulfur trioxide. Because in case of a sulfur dioxide, oxidation state of sulfur is 4. 4 oxidation state sulfur is less stable compared to the 6. 6 is more stable oxidation state. Therefore, it tries to get converted into sulfur trioxide. Because of the resonating structure, resonating stability, it exists in sulfur dioxide. So here we observe the canonical structure of or angular structure of sulfur dioxide. So after resonating structure, it gets stable. After getting stability, the resonating structure is or hybrid structure is like that. Okay. So in the hybrid condition of sulfur dioxide, all the sulfur oxygen bond is same. Okay, both bond length is same in hybrid structure, but here there is a difference because here one double bond, here single bond, here single bond, here double bond. Because of that, bond length is different. But in the hybrid condition or stable condition, the bond length is same. Okay, so it is angular structure. Next, what are the chemical properties of sulfur dioxide? Chemical properties. What are the important chemical properties of sulfur dioxide? What is the behavior with the different compounds, and what is the oxidation property, what is the reducing property, and all that. So under chemical property, we studied the behavior with water and the stability of sulfur dioxide, reactivity of sulfur dioxide, oxidation property, and reducing property, and all that. Sulfur dioxide is a good reducing agent. It reduces the iron +2 to +3, +3 to +2, and all that. Okay, it reduces the iron from +3 to +2. So it is a good reducing agent. Before that, we studied about the solubility and formation of a sulfuric acid. When sulfur dioxide is react with the moisture, gas, react with the liquid or moisture vapors, then it get converted into H2SO4. Okay, so here to balancing the equation, we should multiply here H2, here S, here. Okay, first it get converted into HSO3, next minus, and it get converted into H2SO4. To balancing this equation, multiply here 2 and 2. The balancing is not required here. Okay, when sulfur dioxide, so it's a general thing, it's a very important thing for your knowledge purpose also. Sulfur dioxide, when sulfur dioxide is react with the moisture, it get converted into sulfuric acid. So therefore, sulfur dioxide is a toxic. Suppose we inhale or large concentration of sulfur dioxide gases, suppose inhaled, it absorb the water molecule that present in our body and get converted into sulfuric acid, and it irritate or burns the human system, or in case of inhalation of sulfur dioxide, burns the lungs also. So therefore it may causes the death also. Therefore it is a toxic. It behaves like a toxic and a very harm gas. Okay, it's a harmful gas. Suppose a sulfur dioxide is falls on our skin or a human body, then irritate and burns the skin also because of the conversion of this one. In a dry case, it does not causes any irritation. Okay, so this is about the sulfur dioxide, the important property of sulfur dioxide and the chemical reactivity. Next, it acts as a good reducing agent. Reducing agent. How? When iron Fe3 plus iron plus 3 oxidation state is made to react with sulfur dioxide, aqueous sulfur dioxide. Aqueous sulfur dioxide means water. Okay, aqueous sulfur dioxide mixed with this water. Then it converts, okay, gas, liquid, aqueous, make it into liquid, made to react with Fe3 plus, it get converted into Fe2 plus. And what are the different things formed during this case? H2SO4s are formed. Okay, so this is the reaction. Fe get converted into Fe2. Here multiply 2 to balancing the ionic equation. Better to write in the different form. Okay, H2SO4 is represented in different form. It forms Fe2 plus H plus. H plus means sulfuric acid and the corresponding sulfates. HSO4 2 minus. So to balancing this equation, 2 here there, therefore I multiply 2. Okay, how many oxygen? 2 and 1 to make it into 2. 2 oxygen, 2 oxygen, 4 oxygen, 4 oxygen. Okay, now I am balancing the hydrogen. Hydrogen, how much hydrogen? 4 hydrogens are there, 4 hydrogen. So what is the need of multiplication of 2? Because to balancing the electrons, number of electrons. Therefore I multiply 2. So this is again one more important equation for your exam point of view. Okay, this is the another important equation. Please remember this equation. There is a possibility of asking the question based on this equation. Complete the equation or identify the product formed and all that. Please remember, any higher oxidation state metal is made react with SO2, then it decreases the oxidation state. Next, when sulfur dioxide react with MnO4 minus, any potassium permanganate react with sulfur dioxide, it get converted into Mn2 plus. Okay, oxidation state is decreases. So this is the another example of reducing character of sulfur dioxide. Okay, so these are the very important, this one is the very important chemical equation for your exam point of view under sulfur dioxide. Then what are the uses of sulfur dioxide? Sulfur dioxide is used in case of bleaching purposes, and it is used to in case of petroleum refining, and also it good reducing agent. For the reducing purpose we use the sulfur dioxide. So these are the things under sulfur dioxide. Next we move on to the compounds of sulfur dioxide. Students, these uses of sulfuric acid, sulfur dioxide is nearly same, and the uses are not important for your exam point of view. Okay, for the knowledge point of view we need uses. Sulfuric acids or oxo acids of sulfurs. Next, oxo acids of sulfur. Oxo acids means hydrogen and oxygen both are present in the compound. Okay, then several oxo acids of sulfurs are observed as similar as that of the phosphorus. The oxo acids of phosphorus, we studied about the structure of the different oxo acids of phosphorus. Similarly, the important oxo acids of sulfurs are, one is H2SO4, another one is H2S2O8. It is nothing but ortho, okay, or peroxy, okay, better to call peroxy sulfuric acid. Next, H2S2O7. H2S2O7. It is a pyro. So in case of this, it has one common name. The common name of the compound is oleum. Okay, oleum. It is sulfuric acid. It is sulfuric acid. It is a peroxysulfuric acid. The structure of these compounds are H S O double bond OH OH. Here again oxygen double bond. This is the structure of one sulfuric acid. Next, structure of peroxysulfuric acid. It is O S double bond O. Here how much O? 1 2 3 4. Correct? Okay. How many hydrogen? 2 hydrogen. 2 OH. Okay. Here 2 OH. So this is the structure of peroxy, because these oxygen make a bond. This oxygen make a bond. Peroxysulfuric acid. And the structure of oleum. Okay. Structure of oleum is S double bond O. Here S double bond O. The two sulfuric acid make a bridge. Okay. Here I made a small mistake. H4. Okay. H4. Okay. OH. Sorry. Here it is H2. Here oxygen double bond. Okay. Sulfur oxygen double bond. Here water molecule is evaporated. Hydrogen get lost. Okay. H2S2O7. Here sulfur oxygen double bond. Here sulfur oxygen double bond. And what are the things remaining? Just observe the compound. Okay, it's a very important structure of oleum. There may be a possibility of asking the question on this structure for 1 mark. Okay, oleum, sulfur, oxygen double bond. In the both the case, S2, 2 sulfurs are there, 2 sulfurs, and how many oxygen? 7 oxygen. 1, 2, 3, 4, 5. Correct. So there are again 2. It is with the hydrogen OH. So this is the structure of oleum. Very important. The structure of oleum. Its structure of peroxysulfuric acid. It's the structure of sulfuric acid. Okay. So these are 3 very important oxo acids. There are several oxo acids, but 3 are very important for your PUC level. Okay. Next. The preparation method is deducted from your syllabus. Therefore, I does not explain all these things. The preparation method is nothing but just I explain in words. Okay. Preparation of sulfuric acid is nothing but a contact process. The sulfurs are burned in presence of oxygen. It gives sulphur dioxide that converted into sulfuric acid, sulfur trioxide. First, it converted into sulfur trioxide. The sulfur trioxide is purified. Okay, it is purified by passing the purifiers or purification chamber. It contains arsenic remover, and sulfuric acid is passed to dry. First it washed with water, again it dried with the help of sulfuric acid, and again passed to catalytic chamber, and it become pure sulfur trioxide. And that sulfur trioxide is again passed through hydrolytic chamber, and hydrolysis of sulfur trioxide gives a sulfuric acid. Okay, it is nothing but just increase the concentration of sulfuric acid. Suppose you have 1 concentrated sulfuric acid, make it into 2. That is the method of preparation of sulfuric acid. That part was deducted. Okay, therefore there is no need of giving the explanation and other things. I just explain the properties. So these properties are very important for your exam point of view. Under oxo acids of sulfur, H2SO4 is the very important thing. Sulfuric acid is very important. Sulfuric acid, what are the properties of sulfuric acid? Okay, just I recall, just I explaining the only properties. properties of sulfuric acid. The first is physical property. Sulfuric acid is colorless, pungent, less pungent, okay, pungent, liquid state, high density or specific gravity, okay, better to explain in terms of a specific gravity, density, okay, specific gravity is 1.84, okay, it is a little bit higher than that of water, therefore sulfuric acid is denser. So density or viscous nature, we observe the high viscous nature in the sulfuric acid, and the boiling point, okay, boiling point of sulfuric acid is more than 611 Kelvin, okay, 611 Kelvin, more than 611 Kelvin, and it freezes around, okay, freezing point is not exact, okay, it's around 363 Kelvin, okay, around 363 Kelvin it freezes, or below 360 Kelvin, 63 Kelvin it freezes. Therefore it acts as a good solvent. Sulphur dioxide also good solvent, sulfuric acid also good solvent. But the property of sulfuric acid, chemical property of sulfuric acid is entirely different from the sulphur dioxide. Sulphur dioxide is a good reducing agent, but sulfuric acid is a good oxidizing agent. Okay? Let us discuss about the chemical properties. The chemical property is very important. Okay? I am end up the video here after the explanation of chemical properties of sulphur dioxide. Chemical properties. When sulfuric acid H2SO4 make it, or when it is react with water, what happened when it react with water? First it dissolved, or very important thing is we should take more care during the addition of water to sulfuric acid because of difference in the density. Okay, first we should add sulfuric acid, after that we should add a little by little amount of water with the stirring, because sulfuric acid, the density of sulfuric acid is higher than that of water. Suppose we directly add the sulfuric acid to water, there is a possibility of explosion. Okay, so because of a sudden change in the density, it goes inside, okay, to the water. So during that time there is a possibility of explosion. So we should take the care during the addition, and we should continuously stir the mixture. Okay, so these are the care we should take during the mixture of water and sulfuric acid. When sulfuric acid is made to react with water, first it get converted into HSO4 minus. Okay, HSO4 minus, very important. Okay, acidic nature. So this gives the justification of acidic character of sulfuric acid. H2SO4 made to react with water, it first gives 1 H plus, or decomposition. So there is no need of taking the water here. Okay, there is no need of taking the representation of water here. It get converted into HSO4 minus and H plus. This decomposition, or better to explain in this form, Ka value is more than 10. Ka value is more than 10. Therefore, it is a strong acid. HSO4 minus again decomposes, gives SO42 minus plus H plus again. This has K value is nearly equal to 10 raised to minus 2. The value of K is a little bit lower. So that indicates acidic strength is lower. So what it indicates, H2SO4 dissociate H plus strong, or tendency of giving the H plus is more Ka value. Okay, so that indicates strong acidic character.